Okay, now you know how to graph functions like this. It's already in polar form with r being the output value. That's kind of like my y, if you will, and theta being my input value. I could take, for example, pi over, let's start with 0. The sine of 0 is 0, so if I plug in 0, I get 0 out. At pi over 6, I get a half. So let's see, sine of pi over 6 is a half. 3 times a half is 3 halves. That's 1.5. So when theta is pi over 4, I'm going to be out 1.5. So that point goes there. I'm using a scale of 1 to 1 this time. At pi over 4, sine is 1 over the square root of 2. So that's 3 over the square root of 2. And that's just over 2. It's 2.12. So at pi over 4, I'm going to be at 1, 2, just a little over that. At pi over 3, I get the sine of pi over 3 is the square root of 3 over 2. Multiply that by 3, and you get 3 times the square root of 3 over 2, which is 2.598. That's close enough to 2.6 for me. So there's 1, 2, 2.6 is right about there. And how far did I get? I need pi over 2. At pi over 2, the sine of pi over 2 is 1. 1 times 3 is 3, so I get 3 here. So this part of this graph looks like this. As it turns out, these other values are going to be symmetrical. So we're going to get values that look something like this. I'm not taking a lot of time on this because it's not the point of this particular video. The rest of my graph looks like that. That looks remarkably like a circle. And the radius of that circle, if I look at approximately the center of that circle, looks like the radius is about 1.5. So I'm going to guess that the radius here is, I'm going to say approximately. I am just guessing. Approximately 1.5. Maybe I'm going to write guess here. Okay, now it looks like a circle. It looks a little egg-shaped on this side, so I can't be absolutely sure. But my point of this video, anyway, is to convert this into Cartesian or rectangular form anyway. So let's do that. It's a little bit tricky, but it can be done. Let's start by remembering that r can be described as the square root of x squared plus y squared, and theta can be described as the tangent inverse of y over x. So I'm going to now rewrite this equation using those two descriptions. Instead of r, I'm going to write the square root of x squared plus y squared equals 3 times the sine of, instead of tangent, I'm going to write, instead of sine, I'm going to write tangent inverse of y over x. All right, not to panic. This looks a little funky, but we've dealt with this before. In fact, here's how I want to look at this. I'm going to draw a triangle, just a generic triangle in quadrant 1, and that's my y, and that's my x, and that's my r, right? This could be any triangle in quadrant 1. X and y are both positive. The same principles would apply regardless of the quadrant. Now, the tangent inverse of this triangle is some angle theta. So if I know my y and my x, if I know those values, then I can take the tangent inverse of those of that ratio, and I'll get some angle. If this is the angle I get as a result of doing that, I can then turn around and take the sine of that angle. What's the sine of this angle? Y over r. So I don't necessarily need to know what this is in order to evaluate this, right? The sine of the tangent inverse of y over x is just y over r. So let's see, can I move this down without, no. Oh, there we go, that's not too bad. So I'm going to rewrite the right-hand side here as 3 times y over r. Because whatever the angle is that the tangent inverse of y over x gives me, the sine of that angle is y over r. So there's my right-hand side. My left-hand side is still the square root of x squared plus y squared. And now I've got everything in x and y except for this r right here. But guess what? R is just the square root of x squared plus y squared. So let's rewrite it again. Left-hand side doesn't change. 3 times let's write it as 3y over, not r, but the square root of x squared plus y squared. Okay, now I need to move this again. I'm not sure I really need it anymore, so maybe I'll move it one more time, and if I need to move it again, then I'll just get rid of it. All right, now this is a bit of a mess, but in order to clear this fraction here, I'm going to multiply both sides. Let's see, can I move this all over? I'm going to multiply both sides by the square root of x squared plus y squared. And on the right-hand side, that cancels. On the left-hand side, I have the square root of x squared plus y squared times itself. So I'm squaring a square root, which means I have just x squared plus y squared. And on the right-hand side, all that's left is 3y. Now, on the surface, that doesn't look too bad, except that we're used to the equation of a circle being x squared plus y squared equals r squared, whatever r is, right? This has an extra y in it. Not only that, but this circle, if it is a circle, is not centered at the origin. Its center is here, so it's clearly been shifted. So I need to do some algebra on this to get it into a form that I can recognize and graph it. I think I am going to erase my axes at this point. In order to do this, I'm going to complete the square. Now I'm going to assume that you all remember how to do this. If I do this too fast for you, then your algebra is not quite where it should be, but I'll say that it may have been a while since you've seen it, so don't panic, just come and see me, okay? So let's rewrite this by subtracting 3y from both sides. X squared plus y squared minus 3y equals 0. Except it's been shifted, and it's been shifted in the y direction. Well, that makes complete sense. This looks to me more or less like a circle that's been shifted up so that its center is here instead of here. Let's take a look at the parameters here. The radius of the circle should be 3/2, right? R squared. R is 3/2, and that's 1.5. So it looks like my guess was right on. It's also been shifted from having a center at 0, 0 to a center at 0, 3/2, which is right there. So this equation is the polar equation of a circle, specifically a circle that's been shifted in the y direction. And notice that y, if x equals r cosine theta and y equals r sine theta, y and sine are associated. So this has got a sine shift or a y shift associated with it. And as it happens, it has a diameter of 3, but that still tells us something about the circle. So now I could take a look at this equation. In fact, I'll do it in a different color. But what if I were to ask you to graph r equals 2 times the cosine of theta? I could do that by saying, well, this is the equation of a circle with a diameter of 2 that's had a shift from the center in the x direction. So I'm going to go from here out to here, and then also in the, try to find some symmetry there. That's the equation of that circle. Now we could find that, we could convert this into rectangular coordinates in the same way as I did this one here, converted it into these rectangular coordinates. Or as you'll start to see, we can start to recognize that this is going to be the equation of a circle. It's going to have a diameter of 2. It's going to be shifted from the center, having a center at 0, 0, to having a center, in this case, of 1, 0, halfway across the diameter 2 circle. and it's shifted in the x direction because x equals r cosine theta. Okay, that's really all I wanted you to get from this video. There are several examples in your textbooks and a couple of try it problems. I would encourage you to do that, to do those problems, but we're going to do some more of these in class as well. That's it for 8.3. In 8.4, we're going to be looking at polar graphs.